Hello guys, so today I'm going to be doing a presentation on incremental reading, which is a set of techniques developed by Piotr Wozniak aimed at massively increasing the speed, fun and creativity of learning. If you're interested in learning more about incremental reading, I recommend that you join our event on this Sunday. We're going to do a discussion about incremental reading, whether you're just a beginner or a seasoned veteran, whether you use Anki, SuperMemo, Memozyne, whatever. I strongly recommend that you check out the voice chat because they're a lot of fun. So before we dive into SuperMemo's implementation of incremental reading, why don't we first take a look at some of the ideas that preceded it and influenced it. So the first one that I'd like to take a look at is Isaac Newton's Waste Book. It's an example of a commonplace book, which were often kept by mathematicians and philosophers during the Renaissance period. You can see that in the margin he has a bunch of notes and calculations, and here he's writing observations and ideas. And they were basically used as an external memory aid so that he could develop his ideas incrementally over time. The important thing to remember here is that this was not a chronological journal, but rather arranged by subject and then incrementally updated and developed over time by Isaac Newton. Another idea that's pretty popular and related to incremental reading is Zettelkasten. Zettelkasten was developed by a German sociologist by the name of Nicholas Luhmann. He would create all of these physical paper notes and link them together. And he would describe his note-taking and writing practices as engaging in a conversation with the system, because he was able to use these interlinked system of notes to generate new ideas, which massively helped him in his writing. And there are many other examples of systems and note-taking practices that share a lot of overlapping ideas with SuperMemo's incremental reading. Rome Research, Obsidian, and Annie Matuszak's Evergreen Notes are just 3 examples. So a common thread running between all of these systems is that they all augment the memory by acting as an external store of knowledge. All of them support an incremental process in some sense. They allow you to re-engage with ideas over time. They all create a sort of design serendipity, where rather than passively relying on pure chance, you're actively setting yourself up to generate new ideas. I think the best way for me to introduce what incremental reading is, especially to a beginner, is to give my own experience of the system that I was personally using before I came across SuperMemo's incremental reading. You can sort of consider it a caveman's version, a very primitive version of SuperMemo's incremental reading. So essentially what I did is I had this stack of textbooks that I kept on a coffee table next to a chair, and every day I'd get up, go and sit in the chair, and just pick up the first textbook on the top of the stack and start reading. So basically, I'd just read through until I got to something I thought was interesting. Maybe I'd make a note. And then as soon as I saw something which just started to bore me or I just started to feel tired, I'd basically take that book and instead of putting it back on the top of the stack, I'd put it at the bottom and then move the rest of the stack of books on top of that book. And then basically I just continue the process. I would just take the next book off the top of the stack, this time Human Anatomy, and I would read through. And then when I felt I'd got to something that was worth remembering, I'd maybe make a highlight. So while all of these systems overlap with incremental reading, they still can't really be considered incremental reading systems. So what is incremental reading? Based on an article from Piotr Wozniak called The Minimum Definition of Incremental Reading, I've chosen a few of the major features that I consider to be essential to any incremental reading system, and I'm going to step through each of them and show you some examples in SuperMemo of how they're used and what their purpose is. So the first feature that is essential to any incremental reading system is interleaving. To understand interleaving, we can very simply go back to the examples I gave in my own experience. Essentially, rather than just reading through the entire biology book or the entire anatomy book, I switch between them according to my interests and whether I felt tired or bored. You can also imagine Isaac Newton switching between doing these very lengthy calculations and then moving on to his study of optics and drawing some diagrams. The point here is that rather than simply doing one thing, you're switching between different subjects, combining new and old knowledge, interleaving different materials and sources. So the implementation of interleaving in SuperMemo is very simple. I can start reading an article, for example, this article on the brain. And as soon as I reach a point where I start feeling tired or I'm just bored of this article or whatever, I can simply hit next repetition and I'll be teleported to the next article on trees. So what are extracts? Well, essentially, extracts are used to designate that a certain part of the text has a greater value than the rest of the text. It's extremely rare that an article has all of its value distributed evenly across every single sentence and paragraph. Instead, certain paragraphs or sentences will contain 90% of the value, and extracts are essentially a way of separating those really valuable sentences and paragraphs from the rest of the text and giving them a higher priority. In my primitive version of incremental reading, you can consider the highlights that I made as being analogous to SuperMemo's extracts. And in Isaac Newton's waste book, you can consider the notes he was making in the margin as giving a higher priority to the ideas that were contained within the main text. Here's an example of taking extracts in SuperMemo. So imagine that I was reading this article on tree roots, and I came across this paragraph, and I decided that this paragraph in particular contained a lot of really useful information about trees that I wanted to study in the future. What I could do is select the entire paragraph. I could use Alt-X to extract that paragraph. Now that is added as a child under the parent article on roots. Now I can go to this child extract and I can increase the priority. So setting a lower number in this percent text box will increase the priority. So perhaps I could set it down here. And essentially what that means is on the day when this extract is scheduled, I will see it earlier in my queue. The third essential feature of an incremental reading system is the ability to make closed deletions. And closed deletions are a very simple way of turning extracts into flashcard questions. I'll use this paragraph that I highlighted in the anatomy book as an example. In humans, the heart is approximately the size of a closed fist. If I was to apply a closed deletion to this paragraph, I might get something like this. In humans, the heart is approximately the size of a, and then this part is the closed deletion, and this would show up as the answer closed fist on the flashcard. So here's an example of a closed deletion in SuperMemo. Say that I have this extract about the roots of a tree and what they actually do. I could take this part of the extract and use Alt-Z to close it. And then we can look at what that's created. It's basically created a flashcard. So the something of a tree served to anchor it to the ground and gather water and nutrients to transfer to all parts of the tree. Then the answer is roots. And what that will look like when you come across it in your queue when you're doing your repetitions is like this. And then you show the answer and you can give it a grade, whether you remembered or not. So the next important part of any incremental reading system is the priority queue. The queue portion of the priority queue basically refers to your list of articles or books, and the priority part refers to the notion that each article or book in your queue should be assigned a priority based on its expected value. In my primitive version of incremental reading, the stack can be seen as a very simple version of a priority queue. For example, when I finished reading the Tree Biology for Beginners book, rather than placing it back on the top of the stack, instead I placed it at the bottom of the stack. If I wanted to give it a higher priority, I could have placed it, for example, in the middle of the stack, and then I would see it more often than the other books over time. You can also see an example of implicit prioritization in the Zettelkasten system. Because all of these index cards are linked together, what you'll find over time is that you'll have hubs in the network that have many more links than the other cards. When you're writing an article with your Zettelkasten system and you're following the links between cards to generate new ideas, what you'll find is that you'll end up allocating more time to those index cards with a higher number of links. I think the priority queue system in SuperMemo is much easier to understand. Let's take a look. So here you can see a sorted list of all of the articles in my collection. The highest priority ones, those with the lowest priority number, come right at the top, and then I have the lowest priority articles right at the bottom. And each day when I open SuperMemo and I want to do incremental reading, the queue will automatically be sorted for me so that I will allocate most of my time to the most important articles. And if I don't get to the ones at the bottom, then that's not a big deal because they contain less valuable information. I want to briefly mention one more really interesting point about the priority queue. We have a natural and desirable bias towards information that we can easily assimilate into our prior knowledge. In SuperMemo, you tend to prioritize that sort of information more highly, meaning that most of your time in the system is allocated towards effortlessly slotting in new pieces of knowledge into your prior knowledge. The entire system is essentially designed to help you make dendritic progress, gradually extending your understanding of the world at the frontiers of your prior knowledge. This contrasts very strongly with forms of linear learning, such as in the traditional education system, where the semantic distance between your prior knowledge and the thing that you want to learn is too long, and so you're just not able to assimilate it into your prior knowledge. An incremental reading system can't really be considered complete without spaced repetition. With spaced repetition, you're repeatedly shown articles and flashcards over time so that you're able to re-engage with old ideas and concepts. It also allows you to maximize the amount of high-priority knowledge stored in your memory at a given time. This is probably one of the most important features of incremental reading, and I think it's one of the features that most of the other systems that I mentioned before lack. So each day, the SuperMemo algorithm is going to try and show me those flashcards that it thinks that I might forget. And by recalling the answer of each flashcard, it's going to reconsolidate the memory and strengthen it. And that will mean that that piece of information can last for a longer period of time in my memory before it needs to be refreshed again. Okay. Finally, let's link everything together and look at the flow of knowledge through an incremental reading system. So here you can see an example of me going through my learning queue for the day, and SuperMemo is going to interleave flashcards, articles, and materials from many different subjects. So straight away you can see that SuperMemo is showing me some flashcards to make sure I remember this information about trees. Now it's showing me an article, and I found these two paragraphs to be especially interesting, so I extracted them. Finally, I found this interesting sentence, and I created a close deletion card so that I can be reminded of that information in the future. So essentially, the entire purpose of the system is to efficiently convert passive articles, books, and extracts into flashcards that use active recall to maximize the amount of knowledge that you can store in your memory at a given point in time. This is essential because knowledge stored in the mind forms the backbone of human creativity. Any creative process requires a great deal of inferential knowledge that you can call upon during problem solving, or when you're writing a book, starting a business, and so on. To emphasize this point, I want to quickly review the mechanism of creativity in the human brain. You can basically think of it as a kind of search process, and its goal is to find useful associations that you can use in problem solving. An important point is that the mechanism of creativity is an internal process for the brain that depends on prior knowledge stored inside your memory. Interestingly, the mechanism of creativity can be both conscious and unconscious. It can be conscious, for example, when you're actively trying to solve a problem and thinking about what the next step to solve the problem could be. But it can also be unconscious, for example, during sleep. To link this back to the systems that I showed you at the beginning of this presentation, for example, the Zettel custom system and Isaac Newton's Commonplace book, they both take a similar approach in that there's a dividing line between the knowledge stored within the brain of the human and the knowledge stored within the external system. This for me is really the critical difference between SuperMemo's implementation of incremental reading and the other systems that I described earlier. Rather than treating the knowledge stored within the learner's mind and the knowledge stored within the external system as separate, SuperMemo emphasizes the use of spaced repetition to maintain the knowledge stored within the external system inside the learner's mind. Given that a large body of inferential knowledge underlies many different creative processes, and given the efficiency of the spaced repetition algorithm, this creates an extremely well-optimized process to support learning and creativity. So that's it for my introduction to incremental reading. A reminder to join the discussion on Sunday if you have time, and tweet at @xsparrowlearning on Twitter with any feedback. Thanks, guys.